Good morning, everyone. Today we're going to start working on oblique triangles. So this is a new topic for us, and it's going to kind of change the way we look at things as far as sine, cosine, and tangent. We are going to get some new formulas today, but the good news is you are not going to have to memorize any of these formulas. You're just going to need to know how to use them. These formulas will be given to you on the test. These next two sections are going to be on the chapter test. There'll be a couple questions on them. They are not a major portion of the test. Most of the test still is the SOHCAHTOA stuff we did from earlier. But this is going to just give you a little bit more information about it. And again, law of sines and law of cosines are two things we're going to work with, and those things did appear on this year's ACT exam. So I want to make sure that you are at least exposed to them before you get to the ACT, because all of you are going to be taking Algebra 2 next year, and there's no trig there, so you need to at least see what law of sines and cosines looks like before you get to the ACT, so you have a chance on that. By the way, they do give you the formulas generally on the ACT as well for these, so again, nothing you need to memorize. We're going to start, though, with something really interesting. We're going to standardize our variables for the triangle. So because we no longer have a right triangle, we're still going to generally have a largest angle instead of a right angle, and we're going to call that angle in most cases C, and the other two angles of our triangles are going to be A and B. We're also going to call our sides A, B, and C. Now that can get really confusing, so the way we distinguish this is our angles are going to be indicated as uppercase letters, so A, B, and C, and our sides will always be lowercase letters, A, B, and C. And you'll notice that side B is always opposite angle B, side C is opposite angle C, and side A is opposite angle A. This is important. The standard notation is going to be really important for us in our formulas, because our formulas depend on triangle ABC and sides ABC. So the angles and sides all have to be A, B, and C. Remember, capital letters represent angles, and lowercase letters are going to represent sides. Now, first topic before we get into law of sines and cosines is going to be area of a triangle. How do I find the area of a triangle? The area of a triangle formula you've always known is pretty basic, one you've seen for years. We always say it's 1/2 base times height, or sometimes you write it base times height over 2, same thing. That's our general formula. But to do that, we always need to know the base and height of the formula. What trig is going to do is going to allow us a new way of finding the area of a triangle. The first thing we're going to do, though, is we're going to define a new variable to represent the area of a triangle, and that's going to be the variable k. Okay? So we're going to say k equals. K is going to be a variable representing the area of a triangle. Why is it k? I don't know why it's k. It's just always been k. Every book I've ever looked in, it's always been k. It's just a standard variable that gets often used for the area of a triangle. Now, there are two new area formulas, one of which we're going to worry about today. Another one I might expose you to tomorrow if there's time, because it doesn't show up in the homework and it doesn't show up in the book. It's kind of nifty. It works with when you know all three sides of the triangle. You can find the area of the triangle just by knowing the lengths of the sides. So it's kind of useful, but it's not going to be your homework. It's not going to be your test. So I may cover that tomorrow. Ask me for it tomorrow or another day, and I'd be happy to show you the formula. It's just a relatively simple formula, but not one I'm going to burden you with at this point. The big one we are going to use is this one, k equals 1/2 AB sine C. Notice that A and B are lowercase, so those are representing sides. C is uppercase, capital letter, so that's representing an angle. So basically, if I know two sides, A and B, and the included angle C, I can find the area of a triangle. This formula has multiple variations. It can be 1/2 BC sine A or 1/2 AC sine B. Notice that the angle is always the angle that's not one of the two sides. So what it's saying basically is I have a side angle side situation here. And when I have a side angle side situation, that's when I can use this formula. So I have two sides and I know the angle in between. And when we have that, we simply plug the numbers straight into our formula. It's very simple. The area is simply, in this case, 1/2 times 8 times 13 times the sine of 94. We simply plug that into our calculator, and we can very quickly find our area. So I'm going to do that on my calculator real quick. And 0.5 times 8 times 13 times sine 94. And we get 51.87 units. So the area of this triangle is 51.87 units squared. Okay? And I did go to 2 decimal places. We probably actually will only often go to 1, so 51.9 units squared would have been fine as well. But yeah, I mean, it's simply plugging it into that formula. This only works, though, if we're in this configuration. If, for example, this 8 was over here and it wasn't the included angle, then we'd be out of luck. We would not be able to find the area of this triangle using this formula. Okay? It has to be a side angle side situation. We have sides on either side, and the two sides that make up the angle are the two sides that we know. So it has to be that situation in order to use this formula. I think pretty much all of them that we give you have this situation. It's just a matter of using the formula. So here, let's try setting this one up. First, we have to confirm, do we have the right setup? Well, I got this side that's 17, and I got this side that's 18, and I've got the angle that's made up by those two sides is 49. So, yep, sure enough, I can go ahead and find the area of this triangle. So, K equals 1/2 times 18 times 17 times the sine of 49. So we simply put that in our calculator. 17 times sine 49. Make sure you hit the sine button, not the cosine tan, because it will mess you up. And the area of this triangle is, to the nearest tenth, 115.5 units squared. That's supposed to be a U. Okay. So it's a pretty straightforward process. Nothing that's too terribly difficult. I think you'll like these problems when you run into them. They'll be pretty quick. You pop in your calculator and you do stuff. Okay. One thing you will notice about the formulas we're using today is we are moving away from the whole idea of SOHCAHTOA because we don't have a right triangle anymore. We don't have an opposite, adjacent, and hypotenuse anymore because we don't have a hypotenuse. It's not a right triangle. But we can still use the value of sine 49 or the value of cos 72. But now we actually expand to have all angles, as you saw in this previous example. We never did sine of 94 before. Sine of an obtuse angle, or cosine of an obtuse angle, or tangent of an obtuse angle. And we are going to start seeing that. We're going to have just about any angle that we can take the sine, cosine, or tangent of. We just have only done it up to 90 so far because we've only had right triangles and acute angles at that. So now we can have any angle. All right, now the main part of our lesson. The triangles is just kind of a quick intro. The law of sines. When we have an oblique triangle, ABC, with sides also lowercase a, b, and c, again, the lowercase a is opposite the capital A, the lowercase b is opposite the capital B, the lowercase c is opposite the capital C. Okay, everything's opposite. When we have that situation, the following relationship is true in any triangle. That the ratio of sine A over side A equals sine B over side B equals sine C over sine C. Or we can also do the reciprocal of that relationship and put the sides on top and the sines on bottom. It really doesn't matter. We just need to be consistent. So either set of ratios can be used, and it works wonderfully. Now, of course, since there are three things in the ratio, if we're going to solve this using a proportion, and this takes us right back to chapter 8 where we did proportions, we just do two at a time, or maybe it's these two, or maybe it's even first and third that we're setting up and solving our proportion. But of course, we don't try to solve a proportion with all three at once. So this is our law of sines. and it works pretty nifty. Now, remember when we get into a triangle, if I know two angles in a triangle, I can very quickly find the third. So do not be afraid to do that. In fact, you are going to be required to do that in many cases, once you know two angles, to immediately solve for the third by adding up to 180. But an important thing to remember, we're very used to working with right triangles, is these are, for the most part, not right triangles. These are oblique triangles. Now, in order to use law of sines, we need to know at least one side and the angle opposite that side in order to proceed. Because I got to at least have one of these ratios, sine over A over A, sine B over B, sine C over C. One of these ratios I have to know both parts of in order for me to set up and solve this. If I don't know both A and side A and angle A, or side B and angle B, or side C and angle C, I don't know that, I'm not going to be able to solve the proportion. I'm going to have too many variables. So if I have a side angle side situation, like we had for the area, like we saw back here, I would not be able to actually apply law of sines to find the third side, things like that here, because I don't know anything opposite anything else. Side angle side, it's not, law of sines will not work. Angle, angle, angle clearly will not work, because angle, 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 we don't even know what kind of triangle is. That just gives us similar triangles. We know it could be any scale. And side, side, side also does not work. If I know all three sides, I will not be able to use law of sines to solve that triangle. Okay? So I have to know at least one side and one opposite angle. When I do know one side and one opposite angle, setting it up is pretty quick and easy. And this is a great example of it right here. So I've got this triangle, and I know that this is side B over here, just to note it. Angle B is here. This is side B. This is side C. This is side lowercase a. So we know which is which, always the opposite sides. And I can quickly set up my law of sines. Now, I chose to put the sides on top for no particular reason. So I put the numbers on top and the signs on bottom. It doesn't matter. If you'd have flipped it, it would have been fine. And I fill in my law of sines. Well, so A over sine A is 20 over sine A. Well, angle A is 115, so 20 over sine 115 equals B over sine B. B is 11 over sine B is unknown. And C over sine C, I don't know either one of those. But what I do know here is enough. What's circled here clearly shows there is where I can set up and solve my proportion. So what we do is we're going to go ahead and we're going to solve for sine B as a decimal by cross multiplying. So I get 20 times sine of B equals 11 times sine of 115. And then I'm going to go ahead and divide both sides by 20 to figure out what sine of B is. So now to figure that out, I'm going to take 11 times sine 115 divided by, that's supposed to be 20, not 26. Okay, but I do need to be a little careful here, because when I do, in my calculator, when I hit sine, it automatically puts the parentheses in first. So if I do 115, and if I don't close the parentheses before the divided by 20, if I do 115 divided by 20, that's going to give me something really weird. Okay, I got to make sure that when I'm putting this in my calculator, I'm going to put it all in one string, that I close the parentheses here and then do divided by 20. Or better still, what I tend to do is I'll do 11 sine 115 equals, get a total, and then divide it by 20. That's the safest way. So for as far as keystrokes go in your calculator, that's going to be your best bet, because I don't worry about closing the parentheses. So 11 sine 115 is about 9.9693. We aren't going to decimally approximate that. We're just going to take and hit the division key right away, because it'll automatically use the previous answer divided by 20. I get 0.09 or 0.04, sorry, one more time, 0.4984, etc. Okay? So when I do this, I get sine of B equals 0.4985, we'll say. Well, great. I know what the sine of B now is, but how do I find the measure of the angle? Well, this is where our inverse functions come in. Okay? If you recall, when we did this before, we had this sort of thing. We did sine of B equals a ratio. Now we have it as a decimal. It's no different. We're just going to use the inverse function. So if sine of B equals that, then the sine inverse of 0.4985 equals B. So second function sine of that value, and I get about 29.9 degrees. So B equals 29.9 degrees. Now that I know the length of B, I can solve the rest of my triangle, or the measure of angle B, I can solve the rest of my triangle. Because angle A is 115, angle B is 29.9, so C is 180 minus the 115 minus 29.9. So 180 minus 115 minus 29.9. I guess it would help if I hit the right buttons. There we go. So C is 35.1. Okay? So now I know this is 35.1. This is 29.9. And now I can use the law of sines again to solve for C. This time I'm going to choose the first and the third. So I get the ratio 20 over sine 115 equals C over sine 35.1. When I cross multiply, I get 20 sine 35.1 over sine 115 equals C. So 20 sine 35.1 sine 35.1 equals, divided by sine of 115, and I get that third side is 12.7. And we've solved that whole triangle using law of sines and triangle sum. That's how law of sines works, right there. That's solving the triangle using law of sines. Every side, every angle found out, and it's not even a right triangle. We were able to solve it. This is a powerful tool. Let's try this one. Okay. We're still going to start by identifying our sides. This is A. This is B. This is side C. Okay. I want to make sure my sides are identified by letters so I don't mix up which is which. And now I set up my law of sides. Sine of A, sine of angle A is 40 over side A is 16. Why did I put the sines on top this time and the lengths on the bottom? Arbitrary choice. It doesn't matter. I'm just going to stick with that now. That would equal sine of B over side B, which is 13, equals the sine of C over side C, which I do not know. So once again, I'm in a situation where the first and second parts of the proportion set up in a way I can cross multiply and solve. So I cross multiply this, I get 13 sine 40 is 16 sine B, or divide by 16. And a lot of you will see the shortcut here of just multiplying both through by 13, which is great. But just in case you don't see it, you can do it this way. So sine B equals 13 sine 40 divided by 16. So now I got to figure out what this value is in my calculator. So I'm going to go 13 sine 40 divided by 16. Okay. Don't forget to hit your equal sign. and I get 0.5223. Now again, you have to go to 4 decimal places with these. Very important you go to at least 4. You can go to more if you want, but that's what we need to go to. So now in order to find the angle of B, I'm going to have to do the sine inverse. Okay. So second function sine, and I get 31.5 degrees. Okay, so now I know that B is 31.5 degrees. Now I want to go to angle C. Angle C, well, if one side is 40 and one is 31.5, that's 71.5. So that means that this has to be 108.5 because they have to add up 180. And now I can set up law of sines again to solve for side C. And again, I'm going to go with the ratio where I know them both for sure. So sine 40 over 16 equals sine 108.5 over side C. Again, we cross multiply, get 16 sine 108.5 equals C sine 40. So divide by sine 40. Now, remember, these are values. Sine doesn't cancel out. The 40 doesn't reduce with anything. Sine 108.5 and sine of 40 are values, so do not try to cancel anything out of that. Just put that in your calculator just like it is. So 16 sine 108.5 divided by sine 40, and I get that side as 23.6. We've got everything. I know all parts of that triangle. So generally when solving a triangle through law of sines, you are going to use law of sines twice. That is the norm. You will generally use law of sines twice when solving a triangle. In this particular triangle, it's a little bit different. I know 2 of the angles right away, so I can quickly find my third angle. So I've got 132 degrees used up, so we got to get to 180, so that leaves us 48 degrees short. So this angle is 48 degrees. Okay, this is side B, by the way. I might want to label that. And now I can set up my law of sines. I know all my angles, so I'm going to put my sides on top this time. So A over sine of angle A, which is 48, equals B over sine of angle B, which is 25, equals C, which is unknown, over sine of angle C, which is 107. And now my proportions are actually pretty much set up for me. I'm going to do first and second, and then I'll do second and third. I'll do 2 law of sines here to do this. So if I'm doing first and second, that's A sine 25 is 15 sine 48 divided by sine 25. And 15 sine 48 over sine 25. So 15 sine 48 divided by sine 25. Again, if you're doing it without hitting the equal sign, make sure you're closing your parentheses, your calculator. And I get that A equals 26.4. To find C, I'm just going to do, whoops, I wanted to switch to red. To find C, I'm just going to use those 2. So 15 sine 107 divided by sine 25 equals C. And again, how to get that, I kind of shortcut this time because I knew I was going to see sine 25, but I'm going to bring that sine 25 back under here. So 15 sine 107, close parentheses, divided by sine 25, close parentheses, and I get 33.9 for that third side. So now I've got all three sides of that triangle, and I've got all three angles of that triangle. That triangle is completely solved. That, folks, is law of sines. That's how it gets done. So hopefully you're able to work on that and work on some of these in the homework. Your homework is online this time, but be sure you are showing your work, because I will be checking that work. It's not a worksheet, but I still will be checking where your work to make sure your work is being done on these. So good luck with this, and I'll see you tomorrow.